Hello, pre-calculus student. This video is for chapter 6.1, the last part of graph, sine, and cosine functions. So we are not interested in graphing now. We are interested in the reverse, meaning if I see a graph, I want to write a sine or cosine function that will produce the graph. And most of the time, we like to write a sine function or a sine equation. So look at this graph. It could be written as in cosine if I think of this starting the lowest and then up to the highest. Or I can think of this as starting here and go up and down as a sine function. So this is a sine equation that we want to graph. So in general, a sine function would be a general sine function would look like this: y equal to a sine bx minus c plus d, where we know a control the amplitude, d control the midline, and then 2 pi over b is the period, and c over b is the phase shift, right? So this is what we know in general. So now we're doing reverse. We read off the amplitude from the graph. We read off the midline. We read off the phase shift from the graph, and then from there construct A, B, C, D. So we can also construct cosine, although it is not particularly popular. There is a reason for it. In when you do calculus, you know that sine is preferred one because it's easier to do uh, uh, calculus analysis. So let's look at the relationship between amplitude and ABCD and all those things. Amplitude is how far the graph is from the midline. So if there's no reflection, meaning the graph of sine go from here, go from go from x-intercept to the maximum, there's no reflection, then the amplitude is equal to A. And if there is a reflection, namely you see your graph going down first and up for sine graph, then you know that there is reflection and you have to do, your A would be negative. Technically speaking, amplitude is how much it's, fluctuate from the midline. An easy way to find it would be max minus mean divided to 2. When I say max, a max y divided by the mean y, so this would be 2 times of the amplitude, and you divide by 2, you'll get the amplitude A, the absolute value of it at least. And then D is the midline. Midline is the max plus mean divided by 2 is the middle of the maximum and minimum. So by looking at the maximum y and the minimum y, we can figure out A and D, but after checking reflection. Okay. What about BC, the number that, or the expression inside the cosine and sine? So you would you read the period and phase shift from the graph. And then you figure out what B is by calculating 2 pi over period. Because earlier, to calculate period, when we do graphing, we'll say that is 2 pi over B. So now if we want to find B, it will be 2 pi over period. And then the phase shift would be B times the phase shift that you phase shift on the graph, right? On the graph. You times it, that this would equal to C. Okay, this would equal to C. So this is equal to C. I should say C equal, and this is B equal. Yeah, I think I'm going to add this back as C equal to B times phase shift. Okay, so phase shift is read off from the graph. So if possible, you can also read the midline D. If not, you can calculate it. Good. So let's practice it. So I have a graph, but I want a sine equation. So sine equation, I would expect this way, or down first and up for reflection. So let's look at the maximum first. It is 5 because 1, 2, 3, 4, 5. The minimum y is 1. So I know the midline D would equal to 5 plus 1 divided by 2 is the middle between these two. 6 over 2 is 3. So I can see that the midline is y equal to 3, and it is equal to D. And it's up, right? It's up. Now, if I do the midline here, you can see the sine function start from here. I don't know what it is, where it is because it's not very clear. So we know that the first one start from yeah. So this could be quarter a, a quarter of 0 to pi over 4. You can see the whole cycle, if it is cosine, from minimum to minimum is from 0 to pi over 4. So I know this is one period, although it's not a sine period, but a period is pi over 4, right? I also read off there is a phase shift here, but I don't know. It's very hard to read. It's maybe it's like, so this is pi over 8 to pi over 16. So it's like 1/4 from 0 to pi over 4. So this is half of pi over 4. So this is pi over 8. And I believe this is 1/2 of it. So it's pi over 8, 16. So what can we read off? Do we know the amplitude? Is this how far away these fluctuate from each other? This is 2, right? 3, y equal to 3, which is d, and amplitude is 2. And I don't have reflections. No reflection because the sine curve go up first. I think this one is easier to write in cosine, but they asked us to write sine, so let's try. So do I know A? A is because there's no reflection, and then this is amplitude. A is equal to 2. So we have assembled a lot of stuff. A is equal to 2. D is equal to 3. Do I know B? B is equal to 2 pi over the period, which is pi over 16. So that would be 2 pi times 16 over pi. That is 32. Oh, our B is 32. And C is B times phase shift equal to 32 times our phase shift is pi over 16. We figure that it is half of this loop. Oh, yeah, this is half pi over 4 is pi over 8. Half of pi over 8 is pi over 16. So if I have P times the phase shift on the graph, that would equal to 2 pi. So I have A, B, C, D all figured out. So my sine curve, so my sine function would be y equal to A 2 sine B is 32x minus 2 pi because it's to the right plus D 3. And if I want to do cosine, that's even easier because there's no phase shift. So for cosine, for the purpose, it will be negative because you'd go down. Your low maximum, you're at the minimum first. Cosine 32x and then plus 3 because there's no phase shift. I think it's better to do cosine in this case actually. Let's look at this one. So this is the hours of daylight in Seattle oscillate from a low of 8.5. Yeah, so this is 8.5. In January to a height of 16 so this is 16, July 4th, 16. Determine each of these can be used to model the hour of light from T month after January. So how do I do? Y equal to 12.25? Okay, so they tell us the midline. So D would equal to the midline. In this case, it's 12.25. That's useful. Find a sine function. Or should I do a cosine function? Maybe it's easier to do a cosine function. Use cosine. Because it starts from the lowest, right? So with reflection. And then we know this is 12, right? So this is January. This is December. So 12 would be December. And this is January. So we can just see that the whole period is 12, right? 12 months. And does that end the phase shift? No phase shift. Phase shift equal to 0. This is the amplitude, right? The amplitude is equal to 3.75. We do times -1 because there is a reflection Cosine should have no reflection, so negative 3.75. So this is A. This is amplitude. Our A is negative of it because of reflection. So I have a, do I know B? B is equal to 2 pi over period, which is equal to 12. So it's pi over 6. And then C is B times phase shift. Oh, that is equal to 0, so we don't have to do. So the function will be y equal to A, negative 3.75 cosine B pi over 6 x plus D. D is the midline 12.25. Okay, so that's how you figure out a function from a graph. And this is kind of like the example on how you can do modeling using sine and cosine function.